So, ionic bond, covalent bond, James bond, there are just so many bonds. How can we possibly tell them apart? What determines which kind of bond will form between two atoms within the same molecule? Why electronegativity, of course. Let's break it down with an example. Let's say we are looking at two molecules and their difference in electronegativity is more than 2, like sodium and chlorine. Chlorine, in this example, would steal an electron from sodium. Sodium really wants to get rid of an electron, and chlorine really wants another one. So everybody wins. The result is a positively charged sodium ion and a negatively charged chloride ion. And just like magnets, particles of opposite charge, like sodium and chloride, have an electrostatic attraction. So these two ions stick together by forming an ionic bond. An ionic bond is a very strong attraction because it is happening between ions that have a formal charge. So, in an ionic bond, electrons are stolen, forming a very strong bond. But what if electrons are shared amongst atoms? Well, if the difference in electronegativity between the two atoms is less than 1.7, no electrons are stolen. Instead, the two atoms share the electrons. The electron from this atom feels the attraction from the other nucleus, and so does the electron from this atom. So the atoms share the two electrons to form a covalent bond. Covalent bonds can be polar or nonpolar. If the difference in electronegativity is not high enough to cause ionization, but is at least more than 0.5, like with hydrogen and chlorine, instead of completely stealing the electron, the chlorine will just sort of hold tightly those electrons in the resulting covalent bond. The more electronegative atom in a polar covalent bond pulls the electron density towards itself, and as a result of the slight electron excess, we call this atom partially negative, which we communicate to others with the symbol delta minus. The atom whose electron is getting pulled away is now slightly electron deficient, right? And therefore partially positive, or delta plus. What if the difference in electronegativity between the two atoms within a molecule is less than 0.5 though? Well, if the electronegativity difference is less than 0.5, the covalent bond is said to be nonpolar. In a nonpolar covalent bond, the electrons are shared almost evenly, or if we are looking at two atoms of the same element, they are shared exactly evenly. So the atoms will have no partial charges at all. Other than strange phenomenon like metallic bonding, these are the main ways that atoms bind to one another within a molecule. These are the kinds of intramolecular forces that I want you to know about. So remember, you can predict the type of bond that will form between two elements by comparing their electronegativities. If the difference is very low, like less than 0.5 or so, it will be a nonpolar covalent bond where the electrons are shared almost evenly. If the difference is between 0.5 to 1.7-ish, it'll be a polar covalent bond, where the electrons are shared, but one atom is kind of hogging, holding more tightly to those electrons. And if the difference in electronegativity is above 2, one atom will straight up steal an electron from the other atom, and you'll get ions that are joined by an ionic bond.
So focusing in on our 3 chemical bonds, starting with our nonpolar covalent bond, which forms between elements with almost the same electronegativity. If we were to look on the periodic table at lithium and potassium specifically, we would say these would likely be nonpolar covalently bonded together if they were to come in close contact with one another. However, if we were instead to look at lithium and fluoride, we would not have a nonpolar covalent bond formed between these two elements because their electronegativity is just too different. Now, our polar covalent bonds are between elements with somewhat different
electronegativity. So they're somewhat close together in electronegativity, but they're not almost the same and they're not very different. They're somewhere in the middle. A good example here could be between boron and nitrogen. These guys would be considered, if they came in close contact with one another, they would likely form a polar covalent bond. But if we were to instead take boron and fluorine, these would not form a polar covalent bond. Their electronegativity is just too different. And lastly, our ionic bond, which is between elements with very different electronegativities. If we were to use a similar example as before,
like boron and fluorine, those would form an ionic bond between one another because their electronegativities are so different.
However, boron and silicon would not. Those are too close in electronegativity, right? So those would not form ionic bonds. Now, hydrogen bonds are special and entirely different from the other three bonds we just discussed.